So the project that we did was looking into risk factors for cardiovascular related mortality. Um, the data set that we used was a massive data set that was compiled by the CDC and provided by the US Department of Health and Human Services, which looked into various indicators for chronic diseases. What we did was we narrowed it down to only cardiovascular related diseases. Each data point in the data set is a representative of a study conducted that looked into the proportions of mortality for whatever sample of people that they used. Um, the stratification categories were either race or gender. Um, all the data points were collected over many, many years, and they were done so amongst all 50 US states. Now, the risk factors that we looked into were the time period, the location, the race, gender, and the types of diseases that we looked into as well, uh, or the various different types of cardiovascular related diseases, were heart failure, coronary heart disease, and cerebrovascular disease, amongst many others.
This time series plot shows the trend of cardiovascular related mortality in the United States from 2010 to 2015. The mortality rates have been normalized, which adjusts the values to a common scale from 0 to 1, and this just helps the viewer more clearly compare trends and identify patterns between the different diseases. The plot shows that mortality from all disease categories except for coronary heart disease show a significant increase around 2012, starting in 2012 until 2015. But coronary heart disease shows the opposite pattern, where mortality rates begin high, but show a significant decrease until 2014, and then start to increase again in 2014. Applications of this plot include public health decision-making, health education, and disease surveillance. For example, public health officials could identify which diseases are trending upwards and then educate the public on risk factors of those diseases, suggest intervention strategies that people could implement to reduce their risk, and then repeat the time series again in a few years to evaluate the effectiveness of the suggested risk reducing strategies and make adjustments if necessary. And this could also help identify why coronary heart disease had the opposite patterns from the others and why it had that steady decrease until 2014, and maybe help identify some causes of what caused the rapid increase in mortality for that disease in 2014.
The next graph that we did was a geographical representation of cardiovascular related mortality. Um, Basically, so again, just to kind of restate the same thing, every single data point in the study is a representation of a different, or every single point in the data set is a representation of a different study that was conducted in order to measure the proportion of people who have cardiovascular disease that essentially that have that disease lead to mortality. And this was done on a metric of 100,000 people, or per 100,000 people. Now, what we did was we wanted to see, because this data or these studies were graphed from various different states, from all 50 US states, including Alaska and Hawaii. What we wanted to see was in which states were mortality rates the highest and where were they the lowest. Now, to do that, we wanted to graph a choropleth in order to see some sort of pattern. But to make it more legible, we removed both Hawaii and Alaska and only focused on the main 48 states. Now, one thing that we did was, in order to make the choropleth more legible also, is we took all the data points that, for instance, were part of one particular state, and we aggregated them by taking a mean value. And we did this for every single state. Then all the mean values we normalized on a interval scale, on a continuous interval scale that ranged from 1 to 10. So basically what 1 meant was that the mortality rate in that particular state was the lowest that it could be, whereas 10 was basically a super, super high mortality rate. Um, Upon graphing it out, one thing that we could see is that states that have very large mortality rates were states like California, Texas, Florida, New York, And states that have very low mortality rates were, for instance, Nevada, Colorado, Wyoming, Oklahoma. And so, one type of pattern that we could see from all of this was basically that um, states that have very large urban metropolitan cities, well, people who live there are much more likely to die from whatever cardiovascular disease that they have than the people who live in more rural or in states that have more rural areas.
In the following visualizations, we compare the mortality rates for different types of disease between heart failure, coronary heart disease, total cardiovascular disease, disease of the heart, and cerebrovascular disease. The bar chart shows total cardiovascular disease have the highest mortality rate, and the cerebrovascular disease has the lowest. Next, we will be comparing mortality between gender and race.
Hi guys, this is Priyanka. Before moving to this graph, I am just giving the basic information of this gender and race ethnicity visualization. So I'm just going to representing the comparison of cardiovascular related mortality rate between gender and the race ethnicity. So mainly we are focused on analyzing the mortality rates for the different disease, like comparing the rates between male and female and the different race ethnicities. That we'll see in our next slides. And we can visualize this information using the simple bar graph to make it more accessible and understandable for the non-technical person. The main thing is to provide you the with a clear picture of how mortality rates differ based on gender and race ethnicity, and how this knowledge can contribute to improved healthcare outcome for all. So you can see in the graph which explores the mortality rates by the gender, and by examining this graph, we can gain insights into the disparities that may exist in a health outcome between male and female for the different type of disease. So the height of the each bar, which represent the mortality rate for that disease and the gender combination. The legend is here, which provides the key of understanding the colors used in the bar, which color represent the male and female. So you can see here the highest mortality rate into the by gender, we can say as a male category, and in a cardiovascular disease. So in other compared to the female, male is the highest rate, we can say around the near to the 50,000, and female has the only highest rate in the first stroke disease, and in all other disease category disease, the male has the highest rate. So we can say that male category has the mortality rate the highest ratio. Now moving to the next slides, the race and ethnicity is the same compared to the previous slide. Here is only race ethnicity. Different type of race ethnicity is listed in the legend area. Race and non has Hispanic race ethnicity has the highest mortality rate compared to the all other race ethnicity, and with the other disease also. So by disease wise, we can say this cardiovascular disease has the highest mortality rate, and the race ethnicity is highest in the race non-Hispanic. And for other race ethnicity, by comparing to the other disease, this cardiovascular has the highest ratio, near to the 55,000. We can see here by checking the mortality rate. So this overall this the knowledge is instrumental in developing the targeted prevention and the treatment approaches that address the unique needs for the both genders and race ethnicity listed here. Overall, this visualization provide us with a comprehensive understanding of how mortality rates differ based on the gender, and help us on race, ethnicity also, and help us identify areas where further analysis and intervention may be needed. So this way we did this two simple analysis on the bar chart, using this bar chart. So that's it from my end. Now I would like to transition to my next slide to my team member who will represent the another graph. Thank you for your attention.
Next, we have a parallel coordinate plot of high blood pressure. So this question was posed as rates of high blood pressure among different races, and each point here through the different years represents one of the 50 states. And we can see this across time from 2011 to 2021 and every 2 years during that time frame. From the legend on the right, we can see that each race has a different color that we can see pretty much definitively where that rate falls in comparison to other races. So here we can see the Black population tends to have the higher rates of high blood pressure, and we can see below that it tends to be white. And then down here we kind of have a mixture of the multiracial, other, and Hispanic populations. So as we kind of know, high blood pressure isn't so much about race, but rather maybe the diet a certain race or culture consumes, or whether their exercise is valued. But if everything was held constant, there shouldn't be such a divide in racial disparities among high blood pressure. So that is a little bit of a concern. Other things to note is that some of these populations down here may not have been to the doctor in a while and do have high blood pressure that just hasn't been diagnosed. It's kind of hard to tell that or calculate that. So, in conclusion, we see the highest mortality rate in states with large urban populations, such as California, Texas, and New York, and that could be for several different reasons. Then we can also tell that total cardiovascular disease have the highest rates of mortality, and cerebral vascular disease or stroke has the lowest, and that has to do more within the medical aspect of how it is treated and the severity of the disease. And we can also see from our graphs that mortality from stroke and heart failure has increased significantly from 2012 to 2015, and that's a pattern we have seen globally. A lot of that has to do with the increase in obesity across the population. On the other hand, we do see mortality from coronary heart disease decrease significantly from 2010 to 2014, but we do have a bit of an increase in 2014 from 2014 to 2015. And this is a little bit interesting. We can see across the 20th and 21st century there was a decrease in CHD, but this time frame that we're looking at, 2010 to 2014, if we were able to see more years in our data, we could see that this decrease is not as significant as it had been in the previous 100 years, but it's still interesting to note. And then lastly, we can see that rates of high blood pressure, and high blood pressure is one of the leading causes of these other mortality indicators, that they do have a strong racial divide that we can see across several years and all 50 states.